different perspective about how different engineering programs are doing course design, how course learning outcomes are being designed, how course descriptions are being designed, and then it really helps and builds your learning, and also it's a very enriching experience. Also, in the past nearly 1.5 years, we have been working to develop the course learning outcomes, the course description, the curriculum in a very structured manner for chemical engineering. That has also been a great, enriching, and a very good learning experience for all of us. And we really tried to do a structured, in a very structured manner, using a top-down approach instead of using traditional way of designing course curriculum, then picking out the course learning outcome followed by the other process. We went from the program education objectives to student outcomes, then designed the course learning outcome, and finally, using those course learning outcomes, we came up with the course description. So today, and this brings me to today's talk that will be about course descriptions and field experience or internships in university education. I will try to share the experience of the last year and a half, how we have been doing it in a very structured manner, and this is going to be the outline of the talk. I will start with a very quick introduction because we cannot go directly to course description unless we follow a very structured manner, a very structured process. So I'm going to start with introduction to outcome-based education. Then I will give a brief comparison to the conventional education and OBE, followed by how CLOs are developed using Bloom taxonomy, followed by the course description development, and then in the end, I will spend few minutes on the role of industry training in special correlation to OBE, and finally, or in between, we can also, in fact, it would be nice if we make it more interactive rather than having questions at the end. So, starting with just a little brief about why OBE and why not the traditional education, which probably, if I'm not wrong, most of us have been through or graduated through the traditional education. When we look at conventional education, especially with perspective to engineering curriculum, it is mainly highly teacher centric. So we as teacher have a course content that is given to us, and we start the semester with that course and by the end of the semester we just cover all the course contents, irrespective of what are the skills that are going to be learned or gathered by the students, and also irrespective of how we can measure each technical knowledge, skill, each and every aspect of the course through that curriculum. So I can say also when we look at the students, they are really crazy and running after getting higher and higher grades, just focusing on technical knowledge, a lot of cramming, a lot of memorization, rather than focusing on critical thinking or rather than focusing on skills. So from the childhood, students are molded in a way that instead of lifelong learning, instead of focusing on skills that are measurable, either you get high grades in exams or you perish or you fail. So maybe we can say that conventional education is all about input, that is us the instructors, curriculum, laboratories, other resources, followed by the teaching and learning process, and then students get grades, take exams, and finally they graduate. We are not able to assess how good they are when it comes to creativity, innovation, communication, teamwork, and all the attributes that probably nowadays industry requires, especially in this time and age in the 21st century. If we look at this funnel diagram, we can see that as the time is progressing, there is more and more increase in talented pool of graduates. There are more and more universities, the number of graduates are increasing, but on the other hand, When we look at the HR of different companies, we see this funnel diagram, a huge crowd of graduates, but only a few manage to pass through it. Few days ago, I was talking with my SDP student, and he was mentioning about his cousin who graduated from here. And when he went to a company for the recruitment, what they did after shortlisting, they asked all the candidates to sit in a room and then asked each, irrespective of their grades, asked each one of them to come to the stage and explain what skills do they have. Yeah, technical knowledge, but what else? And those, irrespective of the grades, who were able to explain based on the certification, based on the knowledge, they hired them. Mean precisely for this specific reason. Once I was communicating with the HR of the company during the recruitment drive, and what they said, we hire when we are hiring a new candidate, a fresh graduate, we expect this fresh graduate will be the chief executive officer or the managing director of the company. So we see technical knowledge, design, and all these skills, but also can we see in that candidate that he can be the face of our company? So we have to look into this aspect. Also, I found this very funny but very realistic when we talk with a fresh graduate. So when we see the advertisements, what is written generally, what we are looking for is somebody who is young, 25 years old, but who has 40 years of experience. This is realistically the demand of companies, that a person knows everything, he has worked a lot, but should be young, should be energetic. So this brings us to what are the skills that are required in this century and in this time and age. I was able to gather these three resources from US top employability skills, from Engineers Canada, and Australian Chamber of Commerce. If we just have a look, according to top employability skills of US, the graduate should be highly adaptable based on the circumstances they are working with, who is open to new ideas. According to employability skills of Canada, a graduate should seek different point of view and he should have the ability to evaluate different options and select the best out of it. He should be creative, he should be innovative in finding solutions. According to Australian Chamber of Commerce, a graduate should exhibit initiative in problem solving and problem identification, should apply a range of strategies. So, if we see, it's all about skills, being creative, being innovative, being open to new ideas, being adaptable. And this graph or this chart, I took it from we had a campus recruitment drive of a multinational company. When we visited, we were just having a meeting, and they showed their criteria of selection. We were really surprised that they had technical knowledge. It was important, but it had out of 100, it had only 20 or 25 marks. And in this chart, if you see what are the skills that the industries are looking forward, here the lower the number, the higher is the importance. So if we see, the smallest numbers are creativity. They expect the engineers to be creative. They should have high, not only speaking, but also verbal and non-verbal communication, teamwork, determination, leadership, flexibility. So if you see, yes. What is the determination? So what? Determination means perseverance. Like you are giving a project, maybe you will fail, especially if it's a new project. It depends if it's a literature review, you are doing research, maybe you will fail, but it's not like you will give up. You will have strong desire, strong ambition to keep on going and keeping on. And obviously, all of these traits, during the course of education, we can help students achieve them. Like for example, through projects. It doesn't matter if they fail, but they should have the ability, they should have the perseverance to keep going on. Yes,
One,
yes, please.
in what interrupted. Now, is it based on what? Just only one circumstances or an institution or an organization?
This chart is based on one organization.
Just one point. Nowadays, they talk about emotional intelligence is the most important aspect other than those.
Yes.
So how do you counter that?
It's very, in fact, it's very important. But again, if you see emotional intelligence, it is also something that we do not get from the conventional education. Again, we talk about it as a skill. Just like these skill, again, this is also a skill. So it means that as graduates or as instructors or as departments of teaching universities, it is important that we give the same importance to technical knowledge and problem solving and design through these attributes.
دكتور عاصم I think what Dr. Shams means the mix between creativity and communication together it will be this point.
Yes, like one is a self-aware
Yeah.
leadership, for example. Absolutely. Now, like
And they are
organizing
also linked
discipline
together.
and flexibility. These are
Yes,
there.
exactly. So, when we talk about these skills, there is a Chinese proverb. Sorry, yes, you are sitting so far that
Well, like, example, the issue nowadays is the abundance, right? So much awareness about skills must be acquired, blah, blah, blah. But don't you think still that the fundamental mantra is still the survival? Doesn't matter traditional system or hobby. Survival, which is one of the emotional intelligence, right?
Yes. But isn't it better? Like for example, many of us we learned these skills on the job. Like we had good technical knowledge, but most of the graduates they were able to learn the skills when they were doing projects in the industry, when they were communicating, when they were presenting. Rather than, isn't it better to get them hands-on with the skills during the university so that they can compete with the other graduates in a better way?
Exactly, that's what I'm emphasizing on. For example, so this feedback on the industry, is there an acknowledgement by them, a graduate from certain system is inherited with all these skills or not? If lagging, then what?
Even if not through a certain system, but what we expect, if a graduate is passing through a certain system, he would be able to compete in a better way because he would be exposed to these traits: communication, report writing, teamwork, leadership, rather than just be sitting in the class, attending the lecture, giving exam, and getting very high grades. So, because nowadays, if you see the recruitment process of companies, it's not only like you have a test, technical test, and technical interview. You clear and you get the job. Nowadays, for the good companies, they have like series of recruitment challenges or processes where they ask the candidates to do group discussion. They evaluate their teamwork, communication. Also, there are some cases where they ask them to do certain tasks, where they see how creative they are using some very few things. Can they be creative, think out of the box, and develop something? So until and unless students are exposed to or challenged to a certain extent in the university education, they will find themselves out of place. Uh, you get the point.
Yeah. So I got it. So the industry is just after better than nothing, right? Somewhat better than nothing.
So when we talk about the skills, how can we moving towards outcome-based education gradually? How can we impart the skills to our graduate? There is a very famous Chinese proverb: "You can develop skills. How? Tell me, I will forget." It is just like we give a lecture. Student at the time they would remember, but then do we expect them they will remember it for a very long time? Probably not.
Just one interruption. It is based on learning theory, not the skill. This refers to, like for example, according to some these Russian who got the Nobel Prize. Yes, so it is like you have a register or memory, which is a short-term and long-term memory. Yes. So this is based on the cognitive, not based on what we call the skill.
Exactly, but just like if you see, tell me I will forget, show me, if, like for example, as a mechanical
Just to
engineer,
remember. Yeah. Just to remember, retention, not escape.
yes,
Methodology of returning info.
exactly, and then they would be able to recall it and apply when needed. So show me, I may remember, involve me, and I will definitely understand. Like for example, as a mechanical engineer, if you are learning about centrifugal pump, if you just read something about it, probably you won't understand. If you see it in the laboratory, you would know more about it. If you will really operate it and do troubleshooting with the pump or with the well, you will learn, you have a better chance to understanding the phenomena, how it works. And taking into account this philosophy, how do you think we can help students to collaborate better? By how can we involve them better to learn collaboration, like to teamwork, work in teams, critical thinking, giving them complex engineering problems. So if the students take on, instead of just very straightforward problems which have a very clear solution, probably not. Complex problem is the problem, and engineering problem is a problem which does not have a very clear and straightforward solution. Like you can use this formula and you will be able to find the solution. They have to take into account the sustainability aspect. They have to take into account, for example, there are three processes, and then they use a metrics approach to find out which one is most cost effective, environment friendly, and better for the society. Learn oral communication through by presentation, written communication by giving them projects, by asking them to write reports, learn technology by using technology or developing technology. Develop citizenship by taking on global and societal issues. Learn about careers, do internships, do industrial training, and to learn content means to learn for the overall thing, do involve them in literature review, involve them in research, involve them in reading books, journals, and all of the above. So it means for each of these skills, until and unless we involve them into projects, into something, it would give them better opportunity, better chance to develop the skills. This brings me to outcome-based education, which we feel that it is the best chance to, in a very structured manner, learn and devise and attain these skills. What is outcome based education? Instead of conventional education, which is teacher centric, it is a student centric approach which focuses on skills, knowledge, but each and everything should be measurable in numbers. It ensures student acquires specific skills and competencies, and the process once again is the same. But how it differs, we again have the input in OBE, teaching staff, we have curriculums, we have laboratories, other resources. Then we do the teaching and learning process. We have the students, they pass through courses, they graduate, but in the short term, for each course, we are going to talk about more in the coming slides. We develop short term outcomes, which are, all of you know, are the course learning outcomes. Again, we have long-term outcomes as well, which are also called as program educational objectives. We expect the graduates that our graduates will fulfill the stakeholder satisfaction. They will not just pass the courses, get good grades, and graduate. No, not only that, but they will also meet the requirement of the industry. Who are the stakeholders? Employers, industrial advisors, academic staff, public, parents, alumni. So it means we have to involve them one way or another if we want to have this whole cycle running. We cannot finish until here. We need to have feedback from the alumni. We need to have feedback from the employees in order to really have a better. And this system, in fact, it's not one-way traffic. It's like both ways, and that is what is called COI as well. We do not stop at. We do not get satisfied at something. We keep on repeating and repeating and repeating this cycle so that we can achieve excellence. We now, if compare the OBE with conventional education, maybe we can distinguish them with in five aspects. The focus in conventional education is mainly on the teacher, while here in outcome-based education we have measurable outcomes. So it is student centric. Assessment in conventional education is based on exams and grades, while in outcome-based education we are mainly concerned with the learning outcomes.
Just 1 minute. I have a little bit of, like confusion, or let's say it looks like kind of a buzzword.
Yes.
Let's say we compare, for instance, the educational system in UK and United States. Let's say if you also take into account the formative and a summative assessment. In UK, traditionally, like what you call hit or miss, some kind of thing, right? In United States educational system is different. But let's say when we say conventional system, what is wrong with this? Like British is one of the best institutions in the world in terms of the school.
Yes.
And they're teaching not necessarily it has to be OB. Like these are buzzwords which create a lot of confusion, and there is no demarcating line in terms of clearly identifying what is what.
Still, if you see in UK, if you see the education, especially if you look at the engineering education, it is still like for example,
The school is one of the best in the world. The
yeah.
UK education system. But if you look, the higher education in the United States is completely different. It's one of the best. But then if you contrast,
it's not
as we said, UK is conventional.
Yes, but again, it is not. If you look at the philosophy of it, it is still. It doesn't matter if it is like you have the SOs, which we talk about the buzzword, but if you see the philosophy, it is still based on outcome-based education. It is not just based on like you have this course, you have 7 chapters. As a teacher, I will go and just deliver the lecture. No.
So the concept is that's about
Still, they would involve them in people.
They produce best doctors, best students. But there is nothing wrong with that.
I think this conventional education is a phrase.
It's they have using, right? It's not like it is also based like these are terminologies used without much of a language. No.
Because learning and education is a history, right? If we talk about the British education system, we currently call it a conventional, but it is developing in the 18th and 17th century. Before that, there was some other point. Now we have also adapted. It's also adapted over the years. It's not like we can say that they are just following and following the same methodologies. They are also adapting to because now the demands are very different from the industry, from the job market. Every year we have new demands. Now the industry expect the student should be familiar with AI, with machine learning, this kind of thing, with programming.
I understand that, but let's fixed syllabus. There is no fixed syllabus in conventional education. Almost adapted learning path. What does it mean here? Okay.
Which one are you talking
Like
about?
the flexibility.
Yes. So no, like for example, here what I'm talking about here, like in conventional education, you have a certain course description, and you follow it from the start to the end. What OBE tells us that we have to adapt. And that is what CQI is. At the end of the curriculum, if you do quantitative assessment, I expected the students in heat transfer to get these 5 skills. They should be able to design a heat exchanger. They should be able to communicate the results. They should be able to give theories of heat transfer. If they are not able to at both individual and cohort stage, what would you do? There are processes. You will go back, you will look whether you have to change your teaching methodology, or maybe you have to change the curriculum.
But
Thank you.
this is
Thank you
very
so much.
confusing.
Sorry, doctor. Sorry to
Yeah.
interrupt. Please, because we have, our time is limited, So please, we would like to move the question by the end of the lecture, if you don't mind.
Sure.
Thank you so much.
Thank you. I also have, in fact, a class running
Yeah,
right now.
so this is why I mentioned that.
So,
Thank you.
okay. Now, when we talk about the skills, these are a number of graduate attributes. When we look at Evan, Washington Accord, and AAA, these are recognized as the major attributes that a graduate engineer must have. He must have engineering knowledge, should be able to identify the problem, carry out problem analysis, should be able to create, should be able to design, develop solutions, should be able to investigate based on research, based on literature review, should be flexible, adaptable in using modern tools, should be aware of the actions on society, should be aware of sustainability, engineering ethics, should be able to do individual and also be able to work in teams, should be able to communicate and lifelong learning. These are the traits that we expect that after 4 years or 5 years of engineering education, a graduate engineer must have. And how we as OBE, as an outcome-based education, can try to have these attributes in the graduate, there is a very structured way by which, if we follow it to the letter and spirit, we can quantitatively measure each skill and then keep on advising the students so that by the end, from the start to the end, they are able to achieve all these major attributes that are generally required by the industry. How we do it, the first step is the program educational objectives. By setting the program educational objectives, which means that for each program, mechanical engineering, industrial engineering, chemical, whatever program we are offering, what we expect our graduates to have after they graduate. Not only after they graduate, it is said that PEOs are broader long-term goal that we expect the students to achieve after 3 to 5 years of graduation. There is a lot of debate about it that why not, why 3 to 5 years? Why not if everything is linked? We are teaching, we have CLOs, they are linked with SOs and SOs are mapped with PEOs. Why we can't assess them just after the graduation? They generally, I give an example of cricket, but I think here everybody knows about football. So I will give example of football. Let's say if we are coach and training the football team or a club, PLOs or SOs are these 12 attributes. This is what we want to have them. Like for example, we expect them to be good team player, to have good skills, but can we assess whether we were successful or not? No, we cannot assess them in our coaching center. We have to let them go compete in World Cup. So our POA would be that our club should win the title and Champions Trophy. So it means we cannot assess them in-house. The same goes with program educational objective of engineering programs. We can teach them and we can expect them to have, we can measure the attributes, but whether our PEOs were successful or not, we won't be able to assess unless they have graduated and then 3 to 5 years by getting feedback from their employers, from themselves, we can adapt our our system, whether we are going in the right direction or whether we need to change. So these, for example, are the examples of mechanical engineering PEOs. And if you see, if you read them, I won't read them all, but if you see, they have all the attributes: engineering knowledge, skills, experimentation. We expect our graduates to be good in communication. They should be able to work in teams, leadership, lifelong learning. So if you see, they have all the important attributes that a graduate engineer must have. Now, these PEOs are linked. How they are achieved? They are achieved by SOs. So we have PEO, which are the broader statements, and how we are going to achieve them? We are going to achieve them through student outcomes. Student outcomes are just the list that I just showed you. These are the attributes, these are the skills, these are the competencies that we expect our students to have at graduation. ABBAS, NCAA, Washington Accord, whatever accreditation we take, all these have attributes that they expect the graduates to have. I can summarize them into four. The first one is technical knowledge. So it is expected that at the graduation, students would be able to know the principles of engineering and they will be able to problem solve the problem and they should be able to design. Soft skills are communication, teamwork, leadership. Then we expect the students to be, they should have professionalism, ethics, knowledge of sustainability. They should be a responsible engineers and citizens. And lifelong learning, this means that they should be able to adapt to new technologies, new software. They should be able to do research in order to find out new solutions, even if they have not learned it in their course. These are the SOs of Faculty of Engineering. Just to put them in one slide, I summarize them a little bit. But if you see, they cover all the attributes that all these agencies, Abbott, Washington Accord, or NCAA, ask for. We expect to have a curriculum that will help them in solving engineering problems, in acquiring design abilities, in being effective communicators, ethics and professional responsibilities, teamwork and leadership. They should be able to do experimentation and carry out interpretation of the data, analyze the data, and they should be able to do lifelong learning. So may I ask or just for a few seconds, how do you think we can have lifelong learning assessed, or let's say ethics or professional responsibility assessed through our curriculum? How do you think? For example, engineering knowledge, design, communication, these are very straightforward. We through complex engineering problem, through exams, through teamwork, through report writing, through presentation, it's very easy to assess and give marks. But how do you think lifelong learning can be assessed? uh, Through the curriculum or through exams or through the monitoring. Exit surveys. Sorry? To start with exit surveys. Absolutely, exit surveys, and also through our capstone project is a very excellent example where the students have to do research, find the process. So it means they have a problem where it's not a very straightforward solution, and by doing research, by doing literature review, they solve, they expose themselves to a solution which eventually should help them in the future. To ask me. Yeah. The element of creativity is not here, which you saw in your second or third or fourth slide. So this component is missing. First one. Secondly, your lifelong learning can be assessed not simply because the student is within the institution, but when they go outside. So the return on investment is one of the metrics. Yes, so majority of the organization nowadays they measure effectiveness of institution and effectiveness of the students when they step out. The stakeholder we talk about. Yes. So the return on investment is one of the metric which captures the backlog. What we are expecting in SOs is that we expect that these student outcomes the students would have achieved. We should have measured it. We would have measured it by the time they graduate. So we we cannot wait that long that we would get feedback from the employer and we would be able to know. We want to assess them or we want to observe if the graduates, if the student by the time they graduate, they should be able requires you to have a lag. Without lag, you cannot measure it. Yeah, it's but not living in through case studies, through projects, through the capstone project, you can measure in a way that if because you are exposing still the student to something that he has not been exposed before. So it means he has to learn skill, and by learning that skill, they are able to. That's what happens in our capstone projects. Yeah. So just to save time, I will continue. Uh, In since we have a master's program where we are following NCAA, for NCAA, we have instead of SOs, we have PLOs. So for APIT, we have SOs, student outcomes, which are attributes. In NCAA, we have program learning outcomes. Program learning outcomes, if you see, even though different, but you will see the same metrics. I mean, the same requirements, same skills. So, for example, here we have the knowledge attribute, we have the skills attributes, and we have the value attributes. You can still see identifying the problem, solving the problem, the complex engineering problem, ability to design solution, ability to do problem solving, ability to design, ability to communicate, ability to work individually and as team, ability to do experimentation, be recognized as ethical and professional, responsible citizens and engineers, and be again able to apply new knowledge as and when needed. So even though different, a different accreditation body, but if you see the philosophy or the sense behind it or the background, these are the same attributes which are common in both Abbott and NCAA. Which brings us that whether it is SOs or whether it is PLOs, we eventually achieve them through our courses. And for each course, we have course outcomes or course learning outcomes. So we start with the mission of the university, of the faculty, follow it up with each program PEO, having SOs, which are the graduate attributes. And these graduate attributes, these PEOs are all mapped together and how they are achieved. Just like in a project, we have a work breakdown structure. The first one is the main project goal. The level four is the work package. Just like here in engineering education, we have course learning outcome, which is the key and the most critical part. Course learning outcomes are what we expect the student to achieve when they have finished the semester, finished the course. Course learning outcomes should be very precise, very specific. We should be able to measure it. For example, in thermodynamics, understand thermodynamics. How can we measure it if a student has 50% or 60% achievement? Maybe by having a better CLO, analyze open system by applying the principles of conservation of mass and energy. Now we are in a better position to really judge and evaluate and assess their level of understanding instead of just having a CO understand thermodynamics. These COs or CLOs are generally formed by using Bloom taxonomy. This is an excellent tool that can be used. Bloom, he was a educator, Benjamin Bloom, way back in 1956. He came up with, along with his collaborator, this sixth level of learning. So the complexity of learning was divided in from basic to the advanced level. The first level of learning is remember, like define first law of thermodynamics. So students should be able to remember the definition. Second level or the higher cognitive level is to able to understand. The third level is after remembering and understanding, they should be able to apply the theory, the facts, the equations, the ideas. They should be able to analyze. Analysis means the information break down into part and come up with a solution. The fifth level is evaluate. Evaluation means they should be able to make judgment based on certain criteria. For example, if there are three processes leading to one product, which process is most sustainable, most cost effective? And finally, the last and the highest level is create or design. Initially, until 2001, the four levels used to be the same, but create was level 5 and evaluate was level 6. Then in 2001, there was a new taxonomy level created where create or design, because it is expected that you need to understand the principle, you need to apply, analyze, evaluate. Only then you can achieve the highest level, which is designing a new technology, designing a new product, or design and development of solutions. Bloom taxonomy has three domains of learning. The first one is cognitive, uh, related to our thinking, how we absorb the knowledge, how we apply the knowledge. Second is psychomotor, how we develop the hands-on experience in the students, how we achieve it through our laboratories. And the final one is affective. So cognitive through curriculum, through courses, through teaching, through projects, psychomotor through laboratories, and affective generally in our curriculum. When we look at our curriculum as in a holistic way, we have a number of EMDR courses where we get these attributes: ethics, teamwork, values, creativity, innovation, entrepreneurship, these kind of things. Again, just to give you an idea, the Bloom taxonomy, again, we have the same levels, but for each level, we have a certain verb which when we use, we adapt from here, we adopt from here, we can develop our or create our COs. So for understanding, for example, we can use a number of verbs. For applying, we have for different universities or different institutions, there are some differences. So here I just showed you one example. But for example, for to create, design, develop, it means to design something which has not been done before. Um, Another example of Bloom taxonomy of different levels, and here I liked it because here you can see the way of assessing. So, for example, the evaluation can be assessed through case studies, through projects, through exercises, through simulations, by using critiques on a paper or some article we can expect. But here, if you see, this is the older version. Evaluate is level 6 and create or synthesis is level 5. So, but I like it because it shows some very nice example of assessing these different levels of Bloom taxonomy.
But
Also,
any of this metric, any of the assessment tools can be applied across the board.
Yes,
Not necessarily.
exactly. But I mean, if you really want to assess, create, there are some which you cannot apply. For example, a simple quiz or a simple exam.
Go back. Yeah, like for example, if you use a project and get an
For example,
anybody can apply.
illustrations, examples, it's very difficult to, if you want to evaluate a design project.
Through the case studies project, you can do it.
Yes, yes, exactly, but not through, for example, knowledge or comprehension. Uh, these kind of assessments. So, Bloom taxonomy, it is also preferred that introductory courses or intermediate courses or advanced courses, the levels should be progressive. Instead of using a sixth level for first year course, it is not recommended. It is suggested that in the first and second year, we focus on the first three levels. And then I have a class. I have one question. Yes, please. So what is the one skill you must like students must have as an educator? Should not be compromised. One skill, if you have to choose. The minimum requirement of an engineer is to have problem solving and design capability. Okay, this skill, problem solving. This is the bare minimum. But obviously, nowadays, we call an engineer who should have all the attributes, not just one. Be able to solve the problem. So this means I will now slightly go a little faster because we are just 10 minutes from the finish line. So in the introductory courses, it is expected you start from the lower levels. In the intermediate courses, you slightly and slowly and gradually move towards analyze and evaluate. And in the capstone projects, in elective, in the final year courses, they should be more towards design and creation, where they are able to apply each and everything. I just gave quick examples. So, for example, physical chemistry course, maybe we can, because it is in the first year, define the first law of thermodynamics. Then in the second year course, fluid mechanics, we can ask them to apply. And then in the final year course, for example, power plant and desalination, we can assess the design capability of the students. Some do's and don'ts of using Bloom taxonomy for developing COs. Use precise and measurable verbs for Bloom taxonomy. We avoid vague terms, just like understand thermodynamics, something that you cannot judge, that you cannot assess. Do not use them in CMOs. So, for example, again, another example, understand control systems. Difficult to measure it. How about analyze the performance of control system using MATLAB or using some tool? Probably in a better way, you will be able.
Bloom's taxonomy.
Yeah, yeah,
This
but
is a-
yes, but
this is
if
two
you
different levels.
if you would use
According
this,
to your slide, understanding is the basic or intermediate level.
yeah,
Analyze is a higher level. So therefore,
yeah,
this example doesn't
but
matter.
if you would use this, you can judge that they would be able to understand as well. Unless and until they know the understanding and application, they would not be able to analyze the information. So finally, we move to each CLO, as I showed before, must be mapped to SO. This is accreditation requirement, also the OBE requirement as well. So first we define COs, then we find relevant SOs, and at least one each CLO must be matched with at least one SO. And it is also preferable that each CO must be matched with one SO rather than multiple SOs, because that makes the overall evaluation and overall quantification slightly more complex. These are some examples of different engineering programs, how the SOs of different courses are linked to COs. For example, for a chemical engineering course, the SO1, which is about solving engineering problem, we have a CO which is linked to it. I will skip it, but just to give an example, second is design, third is communication, how a certain specific CO, how we can assess communication by developing a CO which assesses the reports and presentations. Ethics, teamwork, by asking the students to work in groups, through lab work and lifelong learning, again through a certain COs where they learn and then they adapt to new control strategies. So they come across a new problem for which they have not come across before. They learn, do research, and then they apply. Now, finally, moving to our course description. Once we have followed this structured approach from PO to SO to graduate attributes, and then we have developed COs, the outcomes that we expect the students to have once they have finished their course, we can now in a better way develop course description. They will be more in line with the learning outcomes. They will be more consistent, and we will comply with the accreditation. And also on both our part and students part will be more clear, because we will know for heat transfer or any course what are the skills we want the student to achieve. We want the student to be able to design, to understand, be able to communicate. Now we will be able to have a better course description, having the title at the court, credit hours, overview. Also, the overview it is suggested or recommended should not be very long. It should be aligned with the course CLOs and SOs. Here is an example of one of the course. I took it from chemical engineering. So not very short, but not very expanded as well, but covers all the COs that are related to this course. So we expect the student to be able to explain the fundamentals of heat transfer. So in the course description, we have the fundamental modes of heat transfer, conduction, convection, radiation. We expect them to describe heat transfer. We expect them to design. We expect them to conduct because it has a lab. Also, they should be able to. Also, it is suggested that recommended COs should also be applicable to the real world situation or scenarios as well. So we adapt our course description in a way that they are exactly in line with our course learning outcome. So what are the takeaways of course description?
Is this course like a senior course?
This is nearly a senior course.
But
Yeah,
you-
that's why we have the design.
The Bloom's taxonomy, if you match it, it is
It's
at
the highest level.
No, not the designated level.
Like no, if you see the design, design is the create, the highest level, the synthesis level.
This design is like it is a cognitive.
Yes.
It is a cognitive.
Yeah,
So that,
yeah.
but it's not that highest level of.
No, no, no. Design, we have remember, understand, then we apply based on the knowledge that we acquire. After applying, we analyze, we evaluate, and once we are able to evaluate the different processes, now we should be
Yeah, so
able to
if
make
it's
the
a
process.
explain, describe,
And
if it
we
is a senior course like explain, describe, let's say even if I accept this, and
exactly
the demonstrate, so they are on
because
the intermediate level.
exactly because in this course we expect the progressive approach to the student. They should be able to first describe, then taking that into account, they should be able to conduct experiments, should be able to demonstrate, which is similar to apply. And then this is the peak of the course where we expect the students to they should be able to using all this knowledge be able to design changes. So it's a progressive approach that we take throughout the semester. So it is not like in the final semester courses you should have all the COs that are created because eventually it goes in a progressive manner. Uh, what are the mistakes that we should avoid? Should not be too vague, should not be overly detailed, and most important thing, the course description and the course learning outcome. Course learning outcome should follow the Bloom taxonomy level depending on the level of the course, and they should be in line. There should be a certain connection between the COs and the description. This I will share the slides, but this is an activity that we can think about doing with our courses instead of just looking at the course and making it content. How about using a structured approach, starting with what attributes we expect from the course, how we can achieve them through COs, and then use the checklist. Is our course description in line with the COs and the attributes? Finally, I don't think I have enough time, but I will just quickly say something about the industrial training. Industrial training, even I know that here we do not have a direct evaluation or direct linkage of industrial training in our calculation or in our judgment or quantification of COs. But still, it is still the industrial training is something which also has certain outcomes. We do have. Our summer learning has a course learning outcomes. We map them with this. Okay, okay, I was slightly confused. So it is yeah, exactly. So again, because it's really important because we apply, we give them technical skills, we involve them in problem solving when they are doing internship. They are exposed to workplace culture, safety, sustainability. They work in teams on certain projects, and also it is an excellent example of lifelong learning. So it is really, really important that the industrial training where the students from the coursework to the lab work now really are exposed to the actual real world application. It should have key learning outcomes, and they should also be mapped with the SOs. So, for example, problem solving, communication, ethics, teamwork, lifelong learning. This is an example again for the same course, heat transfer item. So if a person is a mechanical engineer or a chemical engineer is working in a refinery and they ask him to write a report based on design and present to supervisor, there are for each internship certain SOs which can be linked together. So best practices of industrial training, we must set clear learning outcomes that Alhamdulillah we have, ensure mentorship and supervision by both faculty here and industry professional. Students should be asked to prepare or submit reports that we have here, and they should also be asked to communicate and present their findings. Conclusion, I must conclude by just again emphasizing on the importance of outcome-based education. That if we, it is easy to follow it by just using the COs, taking the exam, putting the scans, numbers, and then just saying that our CO failed or we passed at the individual level or cohort level. But if we really apply in a true letter and spirit, and we try and emphasize having these attributes, if we aim to have these attributes in our graduates and use a very structured method, like if a student gets very high marks in the CO of communication, we expect the student should be good at both writing and oral communication. So it means our assessment methodologies should be devised in a way, maybe using rubrics, maybe using some other appropriate technique, that we should be able to exactly quantify, and also it should appear when the student is solving a problem, making a design, or doing the communication. With this, I would like to thank you for bearing me for nearly 1 hour.